Good afternoon. How are you guys doing? All right, let me get a little pulse in the room. Raise your hand if you write code for a living or you manage people who write code for a living. Okay. Raise your hand if you would consider yourself a systems or an infrastructure engineer. And raise your hand if you're a systems or an infrastructure engineer who also writes code. Good deal. So, talk today is network automation at scale with Crossplane and Kubernetes. Riveting topic. Hopefully, everybody in here is somewhat familiar with Kubernetes as an orchestration system. How about this? One more question. Raise your hand if you've ever ran a Helm install. So we know what Helm is. Helm is a packaging system for Kubernetes. Allows you to deploy applications. It's kind of like your setup exe if you're old school. Installs your application, gets it running, deploys all the resources you need, all the configuration settings, sets up load balancer services, all the things. So what Helm is to Kubernetes, Crossplane is to everything. So with Helm, you can install a pod, a container, a replica set, a stateful set, a service. With Crossplane, you could deploy a Kubernetes cluster. You could deploy a virtual network. You could deploy an Azure vWAN or a big data database. Anything that's got a REST API that you can talk to, you can deploy with Crossplane. And so imagine if you could Helm the world. What could you build? What could you build at scale? What could you build quickly? What kind of customer self-service could you enable if you could Helm the world? So, the pain you know, the pain that I have felt, is that bespoke automation is killing us. Automation is supposed to save our productivity. It's supposed to make our lives easier. But how many of you have ever built something and automated it, and then you own it for the rest of your life? Raise your hand. Bespoke automation will take your sleep away. It will take your free time away. And so, about 2016, 17, we started a large project. It was a capital campus network and voice infrastructure upgrade. It was 14 buildings in Montgomery, every switch, every phone across the Capitol campus. $22 million project, 3 different companies involved, a lot of automation, a lot of sleepless nights, and all of that automation had to be custom built for that project. Moved forward from that, 2019, started doing projects for the Department of Transportation. We did fleet work, we did roadside work. Who's driven on Highway 280? So there's an adaptive timing traffic system that works up and down the highway. There's a redundant SD-WAN infrastructure that provides networking for that. So if somebody backhoes a cable or runs over a cabinet and kills the power, the rest of the system can try to stay in sync as all you crazy people drive up and down the road. But that custom automation built to enable that particular application. And then raise your hand if you've been to anything at the BJCC down here, at the new Legacy Arena that's been remodeled or the stadium. So 2021, we started putting that infrastructure in. And so that's a big VXLAN fabric, basically, that allows you to plug any device in at any port across that entire campus, and it gets put in the right security domain with the right firewall settings, the right IP addressing. All of that automation, custom built for that application. It's killing us. How many of these custom, bespoke, large-scale automation systems can we build and keep supporting the customers that we've already enabled this sort of automation for? And so, what did we do? How do we overcome this? So, we decided to build a multi-tenant network as a service platform. And so we were able to take our customer onboarding from months of planning and custom development to 3 hours in an afternoon. We enabled customer self-service And then the mythical unicorn of network management, the single pane of glass. May not be the only glass that they have to look at, but in this pane of glass, we were able to consolidate multiple tools that network engineers would typically have to go to deploy and manage their networks. So what are we doing with this platform? So we're currently onboarding 16,000 existing CPE devices across the C-Spire footprint, the company I work for. We manage state-level SD-WAN environments. This is across agencies, even giving like a regional RBAC to, so you think about a civil engineer that's responsible for a part of a state. We're able to give him permissions to manage the network security for his part of the state. And then we're working on, it's in its infancy, an event correlation engine with an organic CMDB. And so as events flow through the system, we're able to correlate the events back to records in our customer subscriber database to create a on-the-fly configuration management database. So how do we go from custom-built automation for every customer to something that allows us to offer this level of sophistication as well as the time to market with the quick onboarding? And so that's where Crossplane came in, because it takes a lot of infrastructure to run a platform like this. There's a lot of security involved. There's boundaries that cannot be broken. You're going to have to go into a customer and argue with their security department, with their architecture team, with their existing network and automation groups. So you've got to be able to prove that your architecture is not going to compromise them. And so by implementing Crossplane, we're able to deploy this very sophisticated infrastructure. And so instead of having to integrate with multiple cloud SDKs, with all of the sprawl of credentials that come along with integrating with multiple points like that, and the months of integration, our app now just uses the Python kubectl client. We use workload identity on Azure, so there's no credentials stored in our backend app. And so that takes us, when we have a new release, we just roll it out to production, and that release is not just software that's running in a container. That release is infrastructure. And it takes it, our time to production is very fast. And so, to just kind of give you an idea of how Crossplane works, if you're familiar with Helm, you have a Helm chart. And so the chart, it's a directory really that has templates and helpers and various things, and you merge the chart with a values file. The values have the parameters that are specific to your implementation of whatever the software is. And so Crossplane, similarly, has this idea of a composition. So a composition is an object that's installed into the etcd database as a CRD. So a custom resource definition gets created that's called a Crossplane composition. So this composition is a YAML file that tells Crossplane what providers and what settings to use to build particular sets of resources. And so the composition gets merged with a claim, which is another Kubernetes object. And so the claim would be what the user or the application would submit into their namespace, which then Kubernetes would say, oh, you submitted a claim for a new VNet or a new S3 bucket or a new database. And Crossplane would see that and say, okay, I'm going to use the composition that you're calling for, I'm going to merge it together, and I'm going to build these resources for you. Now, there is a thing in Helm that's called a values.json.schema that allows you to have a schema for a Helm chart. Unfortunately, most Helm charts out there in the wild do not implement this feature. Raise your hand if you've had trouble finding what the correct Helm values are, if you've ever tried to deploy an app, right? Sometimes they're in the values.yaml that's an example in the chart. Sometimes you're guessing, sometimes you're dumpster diving through their templates trying to figure out what kind of variables they provided inside their code that you could maybe jack into in their values file. With Crossplane, it creates what's called an XRD. So it's a composite resource definition. It's like a CRD in Kubernetes, except it specifies the schema required to instantiate any composition. So it's a totally schema-driven way of deploying this automated infrastructure. Now, where, like we talked about earlier, with Helm, it deploys to Kubernetes. With Crossplane, you're deploying to any API out there in the wild. Then we'll talk about this some more. With Helm, you deploy, you hope everything spins up. What happens if you Helm deploy something and somebody goes into there and say they're running K9S or kubectl and they drop your deployment? Is Helm going to fix it for you? No. It's just going to let it sit there. It's just dead until you figure it out, and then you come back and you reapply your Helm chart. Well, Crossplane runs as an operator, and it's constantly reconciling. But the idea being, if you can understand the mental model for Helm, then you can get to the mental model for Crossplane. So hopefully this isn't too much of an eye chart. On the top left, we've got the beginning of a claim here. And so this is an actual claim that we built for our platform. It's an organization's Azure presence. You have the name, the namespace that it goes into, as well as the parameters. And I only listed one parameter because you don't want to see all of them. But you put this in and you apply it just like anything else. kubectl apply. You can put it in through Flux if you're using some sort of CI/CD to flow your objects into Kubernetes. Once the object's there, the controller's going to pick it up and it's going to start building it. And so here I've done a kubectl get org Azure presences. So, and this takes a little bit of a mind shift here. This org Azure presence is an object that we have created in the Crossplane API. It's now a native Kubernetes object. So I'm checking on the status of my infrastructure deployment with a kubectl command, kubectl get org Azure presences. It tells me it's synced, it's ready, and the age, and of course you can do dash -o YAML and see all the nitty-gritty details. But at the end of the day, this claim and the composition it's based on created these 48 resources in Azure for me. So it's a way to create a very small surface for your developers to use or your application to use, and you're hiding all the complexity for that infrastructure inside the composition that's in Crossplane, and it's actually doing the work and then reporting on you giving you the status of that work. And so people are like, okay, I can do that with Terraform. We've been doing that for years. But just like Helm, Terraform's going to let you have a little bit of drift. You may or may not, if you're really careful, maybe you don't have state file problems with Terraform. I've ran into a few. Running Terraform, where are you running it from? Where are you getting your secrets from? Are you using one of the managed Terraform cloud resources? Or are you using it on some sort of Azure DevOps environment where you're trying to pull secrets from? If you do get drift, do you run Terraform on some kind of scheduled runner and just say apply, and you're still praying, right? You're praying it doesn't break something. With Crossplane, it's running as a Kubernetes operator. And so an operator on Kubernetes has a controller that's running in the background. So it's got this timer. It's running on a loop. And with Crossplane, you can set a timer for each provider. So you can say, I want you to reconcile every 10 minutes, every 5 minutes. If you've got 1,000 or 2,000 objects this provider's managing, maybe you want to extend that a little bit. It just depends on the performance you're looking for and the node you're running it on. But it's doing continuous reconciliation. So this is an example from our team. Maybe somebody decides they need to get access to a key vault. Well, that key vault's got an access list on it. It's a firewall. And they're like, oh, I'm working from home today. I don't have access to that. I'm going to dump my IP address into the ACL. Well, if you're using Terraform, guess what? This dude's home IP address is in your ACL for eternity. With Crossplane, maybe he gets that ACL in there and he's able to get to the secret, but in about 30 seconds or a minute, that rule's gone. State's reconciled. So Crossplane's out there constantly enforcing state. Instead of state files, we've got the etcd database. So we've got a really robust relational database there to store all of this. And then we're relying on Kubernetes RBAC. So with RBAC and Kubernetes, I can say this namespace or this service account has access to this type of composition, and they're able to deploy into this namespace. So it gives me a way to do tenant isolation at the Crossplane level. So how do we accomplish multi-tenancy? So we decided in our application that we did not want to deploy into dedicated subscriptions in the cloud. So our multi-tenancy happens at the application layer. We do auth and RBAC in our API, and then we submit changes to the Crossplane controller through the kubectl, and then Crossplane goes out and builds isolated networks in a shared Azure subscription. At the end of the day, every customer instance is a completely isolated network. They're separate VNets. They're not even connected. They have dedicated compute. They're on AKS clusters. Separate databases and caches, no visibility into other tenants, because we're actually plumbing these environments into the customer environment through SD-WAN. So it's very critical that there's no ability to get between customer environments. But we decided that using one subscription, there's one bill to pay, one cloud relationship, fast onboarding. I don't know who's had to set up a new cloud account and had to deal with accounting and invoicing, and you don't want to do that more times than you have to. And so having that one cloud relationship for us means that we don't have to deal with accounting as we onboard customers. And then from a monitoring perspective, we own the glass. We did not, I think I've got a note here, yeah. The perfect alternative is like, oh, we'll just create a separate subscription for every customer. And if you're a CSP provider on one of the cloud platforms, you get this nice management interface that gives you all of your tenants. But if you've ever used any of their multi-tenant management tools like Lighthouse, I mean, they're one of those apps that the cloud providers put a little bit of effort into, but they didn't really polish it up real nice. It does just enough. And so we decided that for a SaaS operational environment, that one customer per tenant was going to be an operational nightmare. So what are we actually building inside these tenants? So with our Crossplane compositions, when we onboard a customer, they get their own key vault, they get their own storage, their own DNS, zones and entries, reverse DNS. We build VNets, subnets, NAT gateways. We're standing up an AKS cluster with workload identity again, so there's no credentials or secrets needed for any authentication that we're doing in code. And we're also deploying a Cisco ICE cluster for them. So this is not a security software that Cisco makes, and it's a pretty complicated piece of software to deploy. If you're doing a professional services engagement to set up ICE, you're probably paying a minimum of $25K in professional services. Our ICE cluster comes up in about 30 minutes with no engineering. So you can just start to see the value that's being created by automating this customer onboarding process. And then the workloads are deployed on top of this orchestrator, so they get their own CMDB. We use NetBox for the CMDB, a Redis cache that's dedicated to them, and then the orchestrators that are actually performing the network automation. So by putting this complexity into Crossplane and its compositions, its XRDs, its claims, we're putting simplicity into the hands of development. But it's not just developer simplicity we're after, right? Because management, at the end of the day, doesn't really care about developer simplicity. Management cares about time to value. How long does it take from the time that customer order comes in until you can send them their first invoice? And what can we do to shorten that time? That's what management cares about. And so over here on the left, you've got an image of our our dashboard and one of our subscription management panes, you can see I've got an Azure 3-node AKS cluster, an ICE small cluster, a vManage orchestrator, and an ICE orchestrator. And so an implementation engineer, now implementation engineer is not a developer, not even a network engineer, like a tier 1 or 2 support engineer that's helping onboard customers. So this kind of mid to entry level engineer onboarded a $100,000 a year enterprise customer on his coffee break. He submits the claims, grabs his coffee, and in 3 hours, that whole environment's running. So what used to take 2 months, 3 teams, a minimum of $40K in professional services, we can do in an afternoon with very little engineering engagement. Does that seem like that would be beneficial? Yeah. So, here's your plan next week. Install Crossplane in a provider. You can find this on the Crossplane website, crossplane.io. Pick one thing to automate. Create an S3 bucket, create a resource group, create some kind of database, you name it. Start simple. Just build a really simple composition and claim. And then show your boss. Say, hey, look what I built. What could we do? How could we change the way that our organization deploys and manages infrastructure? How can we change our customers' experiences by adopting this sort of technology? And as you dig in, you're going to say, okay, well, what all can I get to with Crossplane? So there's over 70 native providers, but you can also use Terraform. So I gave Terraform a hard time earlier, but for things that we don't have a native provider for, we use a Terraform provider inside of Crossplane. And so that scheduled Terraform runner is actually Crossplane for us. So Crossplane just keeps that Terraform spinning, keeps it reconciled. And then if you want to talk about it, you can reach out to me. There's some of the official Crossplane repos. But I'm on LinkedIn. Here's my email. And I can take some questions. I think we're got a few minutes. The events. So our event-driven architecture rides on top of this. So I was showing here how we deploy our customer-specific environments, but as a part of this, we deploy and manage Kafka clusters, and then we layer multi-tenancy on top of that through our topic design and ACLs that we apply on the Kafka brokers. So we're not flowing the events or the event structure through Crossplane itself. Crossplane's managing more of the infrastructure. So one of our compositions is to build Kafka clusters and Kafka Connect. We also use Kafka Connect to flow our events through into our databases. So all of that is multi-tenant all the way through. Anybody else? All right. Thank you for your time.